Ladies and gentlemen, hello and welcome to what is not the first video on Hazeltest. In fact, there already was a video, a live stream actually, but I would like to do a series of short videos on Hazeltest, and it doesn't really make a lot of sense to kick off a video series on a thing without the first video being at least a short explanation of what that thing is. So here's a short introduction to Hazeltest in a nutshell kind of way. And I would like to kick this off with a question to you. Have you ever been in a 4 a.m. emergency meeting because something somewhere broke in production due to reasons you don't know why yet, with other people just as tired and irritated as you, presumably, and perhaps in order to spice things up a little, there's already some manager breathing down your neck? Yeah, well, me neither. But it's one of the experiences I'd rather not make. And in my opinion, there are only 3 things that people have to do to their release candidates before shipping them to production in companies and corporations of all forms, shapes, and sizes to prevent such emergency meetings from ever transpiring. And here they are. The first one is testing. The second one is testing. And finally, the third one is some more testing. I think that in the realm of software development, testing release candidates is reasonably straightforward, at least conceptually speaking. The implementation might still be tricky, of course, but on the concept layer of things, testing release candidates in software development is rather straightforward, I think, because you can view them at this point as testing, at least, as isolated systems. Bonus points are awarded if your release candidate can be treated as a function in a mathematical sense, meaning same input always yields the same output. Things get a lot more interesting, however, as soon as you increase your testing scope a little, which is something you'll want to do because your release candidates rarely exist in a vacuum in that production environment. Production is truly a magical place, really, where all sorts of merry creatures dwell. And in order for the end clients out there to experience reliable services, these production quote-unquote creatures, i.e. all the release candidates that made it to production ultimately, have to work together in a reliable way, even in the face of the inevitable outage such as, a network hiccup or just a good old RAM failure somewhere downing a couple of servers. Now, because the word release candidate, when taken outside of the world of merely software artifacts, simply describes a uniquely identifiable package that contains some kind of configuration or functionality and/or software artifact, really, that will manifest some kind of behavior in production, we could see other kinds of artifacts as release candidates too. For example, think of a configuration that you want to apply to a database or message queue system, or really an in-memory data grid. For example, if you have a Kubernetes cluster somewhere and you would like to deploy Hazelcast, there's various ways to do that, but one of them probably is to apply a Helm chart to said Kubernetes cluster. And then in that moment, your Helm chart becomes the release candidate. By now, you can probably sort of see where this is going. And indeed, Hazeltest is a tool for automating the testing process of a release candidate that describes a Hazelcast cluster when rolled out to some environment. For example, the release candidate could be a Helm chart, and the environment you roll it out to could be a Kubernetes cluster. The idea of Hazeltest then is to configure it such that it generates a specific kind of load on the Hazelcast cluster under test, start it, fire it up, and then come back after a couple of minutes, hours, or even days, whatever your testing purposes and goals are, and then check whether your Hazelcast cluster has survived. Check the logs for error messages or warning messages that may have occurred, and then from that, derive the fitness of the release candidate that describes this particular cluster. Let me give you a short example of what I mean by that. Just the other day, actually, I load tested one of my client's Hazelcast clusters, very small cluster, only 3 members, and it was doing reasonably okay at first, after I had first fired up Hazeltest, and on the JVM you could see the usual, zigzag patterns of the heap usage going up and down, and things were looking good. But as soon as I increased the number of maps above 500, I think I ended up with 600-ish maps. Even the major garbage collection, so major garbage collection happening is a bit of a bummer in a JVM always, because it kind of stops the entire thing in order to free up, ideally, huge amounts of memory. But it didn't. Instead, we had the major garbage collection kick in, and it was actually not able to free enough memory. So the inevitable happened. After a couple of minutes, the JVMs ran into the classic out-of-memory error. And that's the kind of stuff that should never happen in production, really, because JVM crash means that this particular Hazeltest instance simply, goes down. If you run on Kubernetes, it means it will immediately be restarted. So the restart works without human intervention, but nonetheless, it's always bad if stuff like that happens, particularly if it can be avoided so easily. All you have to do is run a couple of load tests against it and observe, the memory usage pattern, and then make sure that it is able to handle a certain amount of load. Another example for this would be the configuration of van replication, or more specifically, the van replication queue, because in Hazelcast, elements that reside in that queue are stored on the heap. So you can probably already tell where this is going. If you have enabled van replication, then you better make sure that your heap is large enough to hold all of the elements in that queue. Or else, if you ship that release candidate which describes this van replication to production, then you might just see those very awkward out-of-memory errors there again, and you might end up in one of these emergency meetings. And I don't want to be there, you don't want to be there. I think we can conclude safely at this point that the best kind of emergency meeting is the one that never happened. And with that out of the way, let's dive into a very short demonstration of how you can leverage Hazeltest in order to apply some load to a Hazelcast cluster and then see whether it survives that kind of load. What you're looking at here is a freshly installed Hazelcast cluster, and as you can see, there's nothing going on really. It's pretty much sitting there idling, and we got no clients, we got no maps, and we only got 2 members, so it's a very small cluster, and it's been deployed to Kubernetes, of course, because the release candidate, quote unquote, if this were a real use case rather than just a simple demo, is this Helm chart, Hazelcast with Man Center. And if you want to follow along, of course, you can do that by simply doing a git clone on the Hazeltest repository and then navigating to the resources/jobs directory. All you need is a little Kubernetes cluster with enough juice to deploy a small Hazelcast cluster, as well as, well, in this demo, we'll be going up to 2 Hazeltest instances, so a very small Kubernetes cluster should be perfectly sufficient. Now, as I said, this is a very small and unladen Hazelcast cluster, but we're about to change that. So this is the configuration for Hazeltest right there, and as you can see, there's quite a lot of stuff to configure and fiddle with, and it would be beyond the scope of this video to go into all of those details. So let me just sort of get rid of all the stuff we don't need. So disable that and hide it, and disable and hide this as well. And we're going to enable only the load runner. We're going to kick things off very slowly and very conservatively with only 10 maps and 1 Hazeltest instance, and it will only ingest 1,000 entries per map, and they are very small too. Each item is very small too. So yes, I do agree, payload size bytes is perhaps not, it was perhaps not the best idea in the history of ideas to have it specified in bytes, because if you want to ingest some serious load into a large Hazelcast cluster, you're going to end up with a lot of zeros there. So by the time you're watching this might well be kilobytes, but for now it's still in bytes. So let's just deploy that to our Kubernetes cluster and see the kind of load that it creates on our Hazelcast cluster under test. So we got 1 client here now. This should not be particularly surprising since we started one Hazeltest instance. And we got 13 maps in total, 3 system internal and 10 HT underscore maps, which are obviously the maps created by Hazeltest. So Hazeltest is now doing its thing. You can see that we got a couple of entries now, and we can also sort of see the initial CPU spike once those maps have been created and sort of onboarded. And heap usage is now increasing at least a little bit. I'm running the community version of Hazelcast here, so all of the elements will be stored on the heap rather than in the native or off-heap storage. And as you can see, the load we're ingesting really is no trouble at all for this, for even a very small Hazelcast cluster. But we are about to change that. So let's just increase the number of maps a bit. Use 2 Hazeltest instances rather than just one, and actually decrease the CPU requests, so my little Kubernetes cluster is actually able to handle a second Hazeltest instance. And set this over there to true. This will give us 200 new maps in total. 200 because now by setting this to true, each Hazeltest instance will of course receive its always receives its unique ID. And by having set this to true, we tell the load runner to append this client ID to the map name. So rather than writing to, HT load 0, there will be now HT underscore load dash number and then some unique ID right there. So what will happen now is that we'll end up with 210 Hazeltest maps in total. So let's just do another upgrade on our release. And we got 2 new instances coming up. And now the number of maps should be sharply increased. And, well, the number of clients will be increased as well, not sharply, but only a little bit. We'll go up from 1 client to 2 clients, and now we got 210 maps in total. And as you can see here, this is the client ID, right? So this is, as you can tell from the ID, this is a map spawned by 1 Hazeltest instance, and this one is another one. So the heap usage is now sitting at 93 or, close to 97%. So we really do have a little bit of trouble on the heap right now. Memory usage is increasing, and if we take a look at this very nice overview in the management center, now this is all occupied by maps, and free memory on the heap is decreasing. Now the question is, will this Hazelcast cluster survive, given its current configuration, survive the kind of load we just created by spawning 2 Hazeltest instances with different configuration? Now, if this were a real use case and the release candidate, i.e. the Helm chart, would be, something that you consider for shipment to production, given this heap usage, you'd probably already conclude that something is wrong. Because now it would take very, very little to sort of tip the cluster's members over the critical point, and that heap actually running completely full and causing out of memory errors, and as a result crashing members, and that is something that should never make its way to production, right? And if we actually look at the eviction policy for this HT map pattern, perhaps starting eviction if only 10% of heap are still free is, well, a little bit too easy, right? Perhaps we should provide a more conservative value there, or a more defensive value rather. But before we do that, let me actually show you how to actually do that, how to actually push the members beyond that tipping point so they start failing. Because right now this little cluster is doing a remarkable job handling this kind of load, and despite the fact that it's running, that the heap is really that full, we still don't get out of memory errors, right? But of course, there's always more load to be created, and well, it's very straightforward to now create that tipping point, right? We'll simply increase the number of maps to 200 now, and this will give us 400 new maps. So we'll end up with 610 maps in total, although the first 210 are not in use anymore because I just upgrade the existing release rather than installing a new release, because my little Hazelcast, my little Kubernetes cluster is actually not able to spawn more than 2 instances given the current CPU configuration. So, I think I've already reached a tipping point because the management center doesn't actually refresh anymore. So let's check the, oh yeah, no data. All right, so, well, there it is. That was very easy, wasn't it? So if you take a look at that, if you had to make, no, go away. If you had to make an educated guess regarding the origin of those member failures right now, you would have probably guessed it's the out-of-memory error, the classic on the JVM, and of course it is. So now it's time to do something about that. First, let me uninstall Hazeltest release, and then let's actually give it a configuration of the eviction policy that's a bit more, conservative or defensive for the cluster itself. I'll just specify this to be 20, which means that right now, if there's 20% of heap-free eviction will kick in order to simply preserve more space on the heap. So we'll do a Helm upgrade on the Hazelcast cluster as well, of course. And in order to sort of speed things up a little, I'm just gonna kill the existing members. Now, obviously, if I deploy this Hazeltest instance to Hazelcast, sorry, I do mix up the words Hazelcast cluster and Kubernetes cluster quite a lot, don't I? Sorry about that. So if I deploy this to Kubernetes right now, it will give me 400 maps. Right now we had 610, and in order to get the same result, of course, given 2 Hazeltest instances, I'll have to set this to 300 in order to get at least a similar amount of maps. So let's just take a look at our little Hazelcast cluster. Second member is coming up and should be ready any second now. And we're back to an idling cluster, really. This is, well, not yet similar to what you saw initially. But if we let this run for a little bit, then you'd see it's idling now, and we got no clients, we got no data structures. So this is an empty idle Hazelcast cluster again. And now once the second member has come up, which just happened, I'm just gonna roll this out again. 2 instances coming up, and now 600, it should give us 603 in total, 600 Hazeltest maps, and again 3 system internal. So as you can see, the heap memory is filling up very, very quickly, and eviction should kick in now and free up enough memory on the heap so the Hazelcast cluster members can actually survive the current amount of load. So this is a member that doesn't exist anymore. Let me bring up one that does. This one, for example. In a new tab, please. Thank you. Right, so this is the effects of Hazeltest. Creating load. This is the eviction kicking in, and perhaps a little bit of garbage collection kicking in as well. And so far, the cluster seems to be doing pretty okay. Of course, we could go beyond the tipping point again by simply increasing the number of maps. But I think the point was made, and I'm just gonna let this run for a little while now, and then afterwards do a little bit of video editing magic, so you don't have to sit there and stare at a screen, and then we can check the results and check whether the Hazelcast members have actually survived. So here we are 1 mug of coffee later, and our Hazelcast cluster is still alive and running. And as you can see, there are no signs of OOMs whatsoever in the logs. And so if this were a real use case and a real release candidate that you're looking at, and if this were the last test that you want to run against it, you could now safely conclude that this is safe to be shipped to production. Now, the test could be made a lot more interesting, of course, by introducing one replication, because, as I said earlier, the one replication elements are stored on the heap. And of course, you might try other stuff as well. For example, is it able to handle the current amount of load if you decrease that to 15% of free heap? Because at the end of the day, while you want your Hazelcast cluster to be, very resilient towards misbehaving clients introducing or load spikes, really, and prevent Hazelcast cluster members from crashing, you also, on the other hand, want to maximize the amount of memory that is actually available to those clients, because that's kind of the purpose of having a Hazelcast cluster in the first place, right? It's an in-memory data grid. And if you set this to something very conservative, like 40% free heap percentage for the eviction, then that will result in a very, very resilient Hazelcast cluster, assuming that this is stored on the heap, of course. But it will also mean that your clients will have a lot less memory to work with. And in order to give them the same amount of memory, you'd have to scale up your cluster members vertically or scale out the Hazelcast cluster horizontally. And that simply is a matter of money. So, but for now, we know that 20% is all right. And this concludes our little demo for how to use Hazeltest's load runner feature. Here's a short summary of what we just did, because it may not have been that obvious in the heat of battle. So there are 5 load dimensions to a Hazelcast cluster in total, the first being the number of elements across data structures. The second is the size of each element. The third is the number of data structures present in the Hazelcast cluster. The fourth, the number of clients writing or interacting with that Hazelcast cluster. And load dimension number 5 is the stability of the Hazelcast cluster itself. This is a kind of meta dimension, I'd say, because it influences and impacts all of the others. Because as soon as there is a member failure in the cluster, the remaining members have to do a little bit of housekeeping work in order to realign themselves and shuffle around some state. And what you want to avoid, of course, is that a failure of one member triggers a sort of cascading failure of other members too. So what we just did in that little demo was we acted along 2 of these load dimensions. We adjusted the number of clients, although on a very small scale, admittedly. We went from 1 to a whopping 2 clients. And we adjusted the number of maps. This a little bit more significantly. We went from 10 maps at first to 610 maps in the first iteration of our Hazelcast cluster. Then we changed the eviction policy and tried again and created 600 maps. And this was sufficient to kind of show the error that this particular that the first iteration of the Hazelcast cluster configuration, or rather the configuration of that specific HT_map pattern had, and then we adjusted it, and the second iteration of this configuration was able to handle the load. In the upcoming videos, you'll learn how to act on all 5 of these load dimensions using the various bits and pieces of Hazeltest that you saw very, very briefly in the Helm chart before I sort of disabled and hid everything, because it would have been beyond the scope of this video. And I'm not quite sure yet what the next video will be about. Presumably it will be about the load runner. This kind of offers itself because you just saw how the load runner acted in a very basic way in the demo, so that would probably make sense. But if you got other ideas, please do let me know in the comment section below. So this is it for today, and I hope you enjoyed this actually not first video, but first in this video series video on Hazeltest, and happy testing. See you next time.